Working with Nokia, CWME 219. I'm going to talk about 6 gigahertz to backhaul or not to backhaul. We have had a lot of sessions today about enterprise Wi-Fi, site surveys and so on. I can imagine that everybody is asking what has backhaul to do with enterprise Wi-Fi. Well, I will explain that later. I'm also now co-chair of the Wireless Broadband Alliance work group Operator Managed Wi-Fi, where we are creating a reference architecture for all service providers to come to decent in-home Wi-Fi. And why is that so important? Who knows what happened in 2020? I think we all know what happened. There was a sneaky virus putting us all in our homes, full lockdown worldwide. So we all had, all of a sudden, to work from home. And that time I was working with a local company, and I still remember all those problems coming to us. We cannot handle all those Wi-Fi calls. I think a lot of people will also recognize that problem, of course. That period, I don't know how it was in the Netherlands and the other countries here, but at least in Belgium, what I still remember, the first day of the lockdown, it was brilliant weather. It was a brilliant spring, that period. And a lot of people started to construct a garden house and install their desk to work in the garden house. So they needed an internet connection to that garden house. There are a lot of possibilities. Powerline was an option, but that provides with Driessche spectrum, upstream spectrum. So easy mesh or a mesh solution was needed over there. But another aspect or another thing that happened in 2020, and that's April 2020, I think within nearly 2 weeks, it's 4 years ago, the FCC approved 6 gigahertz. It was the first regulatory body that approved 6 gigahertz, 1.2 gigahertz in America. That was the good thing. So here everybody sees again the different channels that have been approved. The US 1.2 gigahertz. In Europe we only got approval at the end of 21 with only 480 megahertz, 500 megahertz. 24 channels in 20 megahertz and so on. This is just a recap for everybody. Interrupt me if you have some questions, of course. But it all starts with a regulatory body. Now, very important with that regulation is that the ERP and the PSD. So in the US, they first started low power indoor, which is the maximum of 30 dBm in 220 megahertz for Wi-Fi 7. But the PSD, that's only 5 dBm per megahertz. That means that for a 20 megahertz channel, you only have 18 dBm of ERP in the US, low power. Of course, that's not sufficient because a beacon, when an EP is transmitting a beacon, that's being transmitted in 20 megahertz. So the range is real limited if you can only send up 18 dBm. Now in Europe, the low power indoor at this moment is 23 dBm with 10 dBm per megahertz. So this is much better. And in Europe it's independent of the bandwidth used. So if you are using 20 megahertz, the maximum ERP is 23 dBm. If you are using 160 megahertz, it's also 23 dBm. So in the US, it's just increasing with 3 dB if you double the bandwidth. Also, very low power has been approved in Europe and also in the US. Now, in US, recently, very recently, so the standard power has been approved with the EFC, the automatic frequency control, where the AP needs to contact the EFC server of the FCC to check which frequency can be used within the 6 gigahertz band. Okay? Now, a little bit of physics. Everybody knows that within Wi-Fi, the higher the frequency, the lower the wavelength will become. And of course, I think everybody knows this kind of pictures, also from the WLA professionals. So it's very nice. 6 gigahertz wavelength, 5.1 centimeter. Of course, if you go to the end of the 6 gigahertz band, so it's already 7 gigahertz, then the wavelength will be even smaller. Now, if you have a shorter wavelength, then we need to think also about the free space path loss. How much of the power do we lose when the Wi-Fi signal is propagating through the air? Suppose that from here until the Wi-Fi signal is reaching Peter and John. So, so there is a big difference between 6 gigahertz, 2.4, and 5 gigahertz. So then on the y-axis, I've put the theoretical maximum ERP. So the orange line, that's, at least here in Europe, that's the maximum ERP of the high power channel. So I took now the channel 105 gigahertz band. So that's 30 dBm. And after that, the 6 gigahertz and the 5 gigahertz low power, that's 23 dBm. And then the lowest one, 2.4 gigahertz, that's 20 dBm. Also the 7 gigahertz is 23 dBm. What do we see is that Wi-Fi signals with a higher frequency will have more attenuation when traveling through space. That's very important because between 5 gigahertz, the high power here, and I took now here the 7 gigahertz, there is nearly 10 dB difference when the Wi-Fi signal is propagating through space. This is huge. This is a huge difference. That's 1 to 2 rooms in a normal house here in Europe, in Belgium, and I guess also in the Netherlands. Yeah? That's very important to take into account. Further, we created also a Backhaul simulator. And now I've put here Wi-Fi 6E and Wi-Fi 7 next to each other. And I compared them with 5 gigahertz, 80 megahertz, 4 streams. And you see that you start quite high. Of course, that's in the most optimal conditions when you have the highest modulation available for the Wi-Fi signal. And it's decreasing slowly until it's crossing the 5 gigahertz signal. And you see that here in Wi-Fi 7, it's quite a big delta, of course. Now, where I want to go for mesh technology in-home network, if you don't have Ethernet in your house, personally I have in every room Ethernet, so I have everywhere 1 gigabit per second speed on my AP towards the backhaul. But if you don't have that, or a customer doesn't have has that, so I think we, as operator and also as vendor, I think we need to try to achieve that over the Wi-Fi mesh. We should also reach around 1 gigabit per second. I know there are now also technologies going above, but I think 1 gigabit should be achievable at least. We made the same correlation with that simulator, and we converted the pathos into coverage in the reach. That's how you see how the 6 gigahertz, 5, and also the 7 gigahertz, the Wi-Fi 7 is changing in reach. Now, for me, very important is that this one here, around 2 gigabit fire rate, we are talking here about fire rate, should be targeted because everyone knows we have losses around because of management frames, control frames, and so on, and also medium contention. So what we simulated here is that with 6 gigahertz, if you want to try to achieve 1 gigabit throughput, we should have around 2 gigabit fire rate, a little bit less. So that's around 10 meters that we are trying to get. Now also from the previous Backhaul's slide, there's one here. So here we are around this point here, that's minus 85, that's for 85 Backhaul's. If you calculate your max ERP of around 23 dBm, with that one, that means that you are coming to minus 63 dBm. That's how I came to that signal. Now, yeah, as a Wi-Fi geek, and I think there are a lot of Wi-Fi geeks here in the room, and the fact that we all need to work at home, and that's not the only one. Our home became also our primary lab, I believe. So correct me if I'm wrong, but for me, my house is also my lab, despite my family members. They are yelling quite often. Now, these figures are also, with these figures I also took into account the previous Backhaul's parameters as discussed before. Now, this is roughly the layout of my house. So it's just quite an easy setup. And at the left on the ground floor there is my root, my easy mesh root access point. And as I reduced minus 63 dBm, I've been looking into my house. I know my house, of course. Where can I have minus 63 dBm around that figure? And that was here. That's the stairs. That's an open hall. And here, at that point, I got minus 63 dBm, Wi-Fi 6 mesh backhaul. I know that another person, a non-Wi-Fi person, will do that, of course. I think that we, from the Wi-Fi industry, we need to provide all the tools to man in the street to give a decent in-home Wi-Fi network. Now, via the cloud tool, I've been checking it, and you see here I've got minus 63 dBm, and also my fire rate, I reached 1.7 gigabit per second. So in fact, that corresponds to this point over here. And if I then recalculate the reach, it should be around 10 meters. Now from the ground floor up to the first floor, the AP on the first floor, I've been calculating, and it was indeed 10 meters for my house. It's 10 meters exactly. So that means that we can effectively simulate where should different APs be placed in the in-home network. That means that we should have the right tools, and then I'm looking eventually to Joel Crane with the Hamina tool, if it can also be, if Hamina can think of a solution for in-home networks as well.
Well, one of the things you're going to need is the attenuation of your ceiling and your walls, right?
Yeah, but I know. What you can also do, it should be a tool. You should comprise that in an app, and with your device, with your smartphone, you should measure also. So you start from your AP on the ground floor, and when you're walking through your house, your smartphone is measuring the RSSI towards the AP, and when it's reaching around minus 63 dBm or 6 gigahertz, then the app should state, hey, here in this neighborhood, you should place the next mesh AP.
If you your iPhone radio is really different than the mesh.
I know, I understand that point. But That's how we should think of it. And of course, I know the APs, they are both 4x4. My iPhone, that's 2x2. That's also a delta. But we from the industry, we need to think of it. And I've seen solutions here like Whitebot, yeah, indeed, that's true. But
this is something in-house, right?
yeah.
So half of your users are not going to understand this. Half of the stuff that your users are going to buy actually do not support anything that does, the high frequency and 5 gig doing 30 dBm. So written down this way, 3, so if it's going to be different. And we also
But
don't
that's,
have 7 gig, right?
I understand the point,
But 4x4 would be nice in my house.
yeah.
4x4.
But that's my point. We from the Wi-Fi industry, that's a point to us. We should make it needed transparent that customers can very easily install all those solutions. Do you understand?
Well, then just one message to 10 meters.
Oh, no, put a line on that, I agree.
It's not always 10 meters because it's good because here for me it's all open. It's just all open. So that's not in every house. So because every house is different, but we should make tools to make that happen.
That's what you need.
Now, so after that, I also did a throughput test, and I was reaching 946 megabits per second. So I was reaching nearly 1 gigabit per second. So that's okay. So 6 gigahertz is definitely a good frequency to use as mesh backhauling for the in-home Wi-Fi networks. Now, as also already explained by Steven from Huawei finally this afternoon, Wi-Fi 7 will become even better for backhauling. We can choose between link aggregation, link redundancy, or link steering. So there, for backhauling, mesh backhauling, we can choose between 5 gigahertz and 6 gigahertz. So that there is more reliability, as also Steven explained this afternoon. But it's up to us for the industry to come to these solutions for the end user. And as already mentioned, a lot of people, there are still too many calls coming in at the operator side. That's it. Are there any further questions at this moment? And I think also, Alain, the figures that I found out by another way, I think they are corresponding to the figures that you've been presenting earlier this afternoon. So I think that's good that AI is also proving the same. Any further questions?
Yeah, where can you buy this stuff?
Excuse me?
Where can you buy this? Is it at like a media market or whatever? Because it's for consumers, mainly.
These ones?
Yeah.
Well, those are just APs from Nokia. Normally, those are sold by operators.
Ah, okay. Like a KPN or whatever.
I don't know. So, this is the Wi-Fi 6E access point for Nokia. That's where I'm testing it. And that's fully compatible with Easy Mesh by Wi-Fi Alliance. It's also supporting Wi-Fi data elements and USB TR369. So TR181 data log. It's fully compatible with standards on the market. Any questions?
What kind of price do these mesh devices have? Because like a standard cluster, so that's the price.
I'm an engineer, not a marketeer, I'm sorry. So I don't know. So that's totally no idea, because there are, I think those are sold to ISPs. Those are agreements. Yeah, and it's, I think it goes with volumes. I don't know. Okay, thank you.
Marijn van Ton, we are 15 minutes before schedule. But Peter will catch you on the talk again.
Wi-Fi 11!
So Wi-Fi 11. Thank you. You're going to have to bear with me because this is not planned. So it was just very quickly, and I'm really hoping this is going to work. Or maybe I can use Joe's laptop.
Bonding.
I'm just connecting to the Wi-Fi.
Oh.
Joe doesn't have HDMI, so I'm going to have to use my laptop. This was just very, very quickly. We'll get there. Does anyone have a Mac adapter for HDMI? No.
USB-C.
Oh, here we go.
I have a MacBook Air, so Tommy can't afford me a laptop.
Yeah. And my laptop's now finally getting there. So it's just like the question in the last presentation was: does Hermina have a solution for home Wi-Fi and match links? And we just thought, yes, it does. And we thought you might like to see it. So here is the solution. I'll let Joe drive. This is a match link in Hermina in the same home that you just saw. Obviously, we can see the mine that's 33 dBm. That was right, wasn't it?
How many dB did you have?
Mine is 63 dBm.
Mine at 63 dBm.
63.
Wow.
Yeah, that's modelled inside Hermina, and you can even see the house in 3D as well.
Very good.
So,
I mean,
and do you know what? Everyone here, every single.
hang on. We can fix it.
Oh no.
And there.
So what's really good about this is everyone here can go and sign up to Hermina for, I don't know if Joe will let me say it's for free. Absolutely free. You don't need to pay anything to have a Hermina account. And you, no, this is true. There's a light version. The light version allows you to draw enough walls to do this, and you can place up to 3 APs. So for designing home Wi-Fi, completely free. Go and try it. It's a special heater discount.
We mostly just want to show off that we made our house. So, I mean, we're basically grown men playing with doll houses at this point. That's what this has evolved into. So anyway, thank you for the opportunity.
Why are we not to the stairs?
But also from my previous company, we were also suffering with the app, with the accompanying app. How do we guide customers to put the APs at the right spot in the house? And that's the main point. Yeah, that's it. But I should do it in an easy way.
This is easy. We didn't plan this, we just did it now.
Thanks.
No worries. Okay, let's take a 20-minute break. And,